Greetings from Saigon. At this point, we're going to be looking at integration or integrals. By the way, I'm actually not in Saigon yet, but I will be when you watch this video. If you watch the video, that is. But anyway, we're going to dive right into it. There is a lot of explanation to be done to understand this completely. And to be honest, I don't understand it completely either, but I understand it enough to be able to do it and think about it at a level of depth that's necessary to teach it. But anyway, let's look at the question. So it's find the area under the curve y is equal to 4x to the third plus 4 between x is equal to -1 and x is equal to 2. And these are called definite integrals because we're talking about a defined area. Okay, and integrals is a way to find the area of within parameters that are not defined. And I don't know if that makes sense, but hopefully I can clarify it. So for example, parameters that are defined is a circle, and we know what the radius is. So we can find the area of a circle by simply using the formula pi r squared. And you know, we just put in the radius and then we find it. But with this, for instance, we have to find the area under a curved graph. And we've seen some of these cubic graphs, so we know that they can get pretty complicated. So just to give you an idea, I tried to draw it, but it's, well, it wasn't pretty. But we're looking between, on the x-axis, -1 and 2. And we're trying to find this area where the blue and the red overlap. So we're looking at the purple region, and we're trying to find that area. And we're going to do that through integration. And this is a definite integral because we have boundaries that are defined, and those boundaries are, again, -1 and 2. Before we proceed, and if you did not watch the video about antiderivatives, or if you forgot how to do them, please review that video. It should be uploaded into Google Classroom. I time-released everything. And so it should be there. So anyway, we're going to do this, and when they say under the curve, they mean between the x-axis and where this curve is occurring, this cubic curve. So here I'm going to attempt to draw it one more time. Hopefully it goes a little better this time. So we're trying to find this area between the x-axis and below this curve. Here we go. And we're going to use this symbol. And this symbol is the same as a summation. So if we're looking at this curve, okay, so anyway, this is the integral between 2 and -1. And please have a look at the problem. That's x is equal to -1, x is equal to 2. We're looking between these two values on the x-axis. And everything in between that's covered on the y-axis. So we're trying to find the area of this region. And what we're going to do is we're going to subtract the integral of 2 from the integral of -1. Okay? And so we're going to start out with this symbol, and this is going to be confusing at first. I'm just going to teach you the mechanics of this, of how to solve these problems. Frankly, that's what this A-Levels textbook does. My assumption is later on in the program, they're going to show you it more in depth. But if you think about it, we're trying to find the area of all these rectangles that are contained within this area. But we have to have infinitely many in order to find the area of this. And that's what we're aiming to do through this process called integration. Again, let's reflect back, definite integrals. That's what we're working on today. And here we're looking at that cubic function. So we're going to go ahead and start differentiating. I said differentiating, I meant integrating. Okay, here we go. I'm adding in a step actually to enhance your understanding, hopefully. You're going to wonder what's happening with the constant. But I want to go back to the problem before we actually begin to solve this, which here's here's the problem, and it says under the curve, okay? So we're looking under the curve and the y-axis. Well, at the y-axis, y is equal to 0. So as you might recall, if we find the antiderivative of y is equal to 0, then we get c. We don't know what the, well, we do, but in theory, we don't know what the constant is. So what we're going to do is we're going to subtract these two once we integrate them. Excuse me. But this is just going to cancel out anyway, because we're going to get c, and we're going to get c with this equation as well. What the heck is Mr. Jolly talking about? I'm going to show you. So we're going to find the antiderivatives of each of these. And don't forget, add 1 to this power, or exponent, or index. Divide the coefficient by it, and do the same here. So I'm going to go ahead and do that step. So I went ahead and found the antiderivative, and I didn't simplify it entirely, but what you're going to want to do is you're going to subtract the area, and I made a couple errors in this paper, please ignore it, but I'm going to find the area between here, where this is, and I'm going to subtract it from this. So I'm going to subtract this curve after we've integrated it from the x-axis, which is y equals 0. And when we find the derivative of y equals 0, we get c. We get a constant. But we don't know what that constant is. Doesn't matter. We get a constant here when we subtract the two constants. So this curve minus this is going to give us our area. Here's what we get. So we find the antiderivative of each. And if we combine these, c minus c is 0. So this whole, when you're dealing with definite integrals, when they talk about the finding the area under a curve and the x-axis, you do not even have to consider the x-axis, and you don't have to consider c, because those are going to cancel out. They're just going to c minus c is 0 in short. So they're just going to disappear. So we're going to go ahead and continue on, and we're going to simplify this. And here's what we have. Now, please be mindful of the notation. So it's between 2 and -1 on the x-axis. So we're going to separate where this graph is his 2 minus where it's at -1. Minus that. So what we're going to do is we are going to take this equation and we're going to subtract our higher x value from our lower x value. So put these values in for x, as you can see what I did here, and I'm going to solve, and we're going to have our solution. And just like that, we found out that our solution is 24 plus 3 square units. 27 units squared. And we did that through integration. I'm going to make another video about this because I think it's a broad concept that needs a little bit more instruction. So we're going to call this integration video 2. The integration video 1 was the antiderivatives one. And just to remind you, we took the antiderivatives of this in order to determine what the area is between these points where x is equal to 2 and x is equal to -1.